Alrighty, folks. Welcome to another BTN podcast. Craig is here. How are you doing, man?
Doing fantastic, mate.
Good. As always to find out. Great as always to find out.
Well, it's the middle of the apocalypse still, so...
Yes. It's getting...
Still a little bit fatigued.
Mm-hmm.
But we'll get through it.
We'll get through there, man. We'll get through there.
Or at least we think so. We'll ask.
At least, we'll find out right now with our guest on the line right now. Richard Allen White. How are you doing, my friend?
Pleasure to be here.
Fantastic, man. Fantastic. So, just to talk about how we got you on, I think we spoke to Kat. Are you known Kat for quite a while?
Yes, she is on TikTok, and so my daughter got me to download the app, and so I started following her, and then I started my own little app, and that kind of thing, and so that's how I met her. Awesome,
man. Awesome. So, well, we done a podcast a while back with Kat, obviously about her side of things.
Yep. And
we were hoping to get your side of things as well.
That sounds great. So let me start this off with a disclaimer. First I'll start off with who I am. So I am Dr. Richard Allen White III. I am an assistant professor at the University of North Carolina at Charlotte in the Department of Bioinformatics and Genomics. I am also the CEO and chairman of Raw Molecular Systems, Inc., out of Concord, North Carolina. None of the things that I'm going to discuss today represent the feelings of either my company or the University of North Carolina at Charlotte. These are my personal, individual opinions on the virus. I am a PhD, computational and synthetic molecular virologist. I've been working on viruses for the last 2 decades.
Mm-hmm. Excellent.
Fantastic.
That's the most in-depth introduction we've ever had on this podcast, so that's awesome.
Great.
Awesome, man. Awesome. So on you go.
If we could start off, because I've had a Google, so I think I get the basics of the differences, but not the full depth of the difference between epidemiology and virology. Could you explain the difference?
So epidemiology is a broader field. Dr. Kat, epidemiologist, who's now pretty famous on social media, her job is more of trying to surveil and understand how disease spreads. And that could be any disease. That could be a disease caused by protists or a disease caused by bacteria. The first kind of modern epidemiologist was actually, I think he was British actually, and he noticed that people were drinking from the same pump down in Lower London, and that's where they had a cholera outbreak. And so once he got people off the pump downtown London, cholera stopped to spread because the source of the cholera was fecal contamination of the public water supply, and everybody was using that pump for water, and so they were drinking the cholera and stuff like that. So that was the first real modern epidemiologist. Obviously, quarantine is actually an ancient word. And so whereas a virologist differs from an epidemiologist is that a virologist studies viruses. We focus on the infection, the replication, the genome, the transcription, the host response to viruses, and we study the virus itself. Whereas an epidemiologist uses a lot of statistics and biology, as well as public health measures to stop the spread of a pathogen to become a pandemic. So that's the real clear-cut difference. One is studying the virus, the other is studying how disease spreads, basically.
Yeah, that does exactly. Somebody asked earlier on, if it was someone the same as Kat we were getting on.
Yeah.
And I sort of explained it the same way. It's like epidemiology is the sort of like the path of an epidemic, like how everything is affected out with the actual virus and why. But you're sort of studying the actual virus sort of thing.
Yeah.
Right.
And the response, and I mean, obviously, there are epidemiologists that are also virologists, so it's not mutually exclusive, right?
Yeah.
So you can have epidemiologists that are more general, ones that are more bacteria or protistan or fungal, you name it. But their job is to understand the flow and spread of disease.
Mm-hmm. There's one thing you said as well. Sorry, before I'll just get this in. You said, and then we have like on the headline here that you're a computational and synthetic virologist. Can you explain the differences like of those two things?
Sure. So computational biologist is a biologist that basically uses, another word is commonly used a lot, is bioinformatician, right?
Yeah.
So it's the using biological information to infer information. Computational biologist does biologist via computer. That's the simplest way to describe it.
Okay.
So computational virologist is a biologist that studies viruses, that uses computer or algorithm, that uses computers and algorithms and high performance computing as well as code in order to solve biological questions. Now, molecular virology is actually someone who studies the molecular mechanisms of the virus, the genome, the transcriptome, the proteome. And then a synthetic virologist is a person that uses engineering principles and molecular biology in order to actually build new tools or new ways to actually defeat viruses or new techniques. Or, I've heard of everything from people making batteries using bacteriophage and stuff like this. And so using engineering principles in molecular virology. Mm-hmm. That's the difference between synthetic, molecular, and computational.
I understand that perfectly.
we will understand all this on like the most basic level, as you will understand, as you will know.
Yeah, so a synthetic virologist is a virologist that uses engineering principles in molecular biology. That's the simplest way to describe it. Perfect.
Simple is easy for us. That's perfect.
If you could dumb down to a significant level.
But this is what I like, because like a guy that sort of goes that in depth with like,
you can answer questions properly.
You can answer questions properly, as like, because I see on like the news channels and stuff, what people tend to do is get a healthcare worker in to explain some of the certain things,
or a GP,
somebody like that. Nobody ever really concentrates on getting like somebody that's like in depth with the work that you guys are doing.
Yeah, I think you've hit it nail on the head. We need to do better at literacy in science. We've talked for 30 years on how to increase literacy for reading and writing and mathematics, but I think we are ripe for a time to increase general scientific literacy. Mm-hmm. I think the only way we can prevent us repealing back to a dark age when people didn't believe in science and they thought diseases spontaneously occurred is to have everyone increase their general scientific understanding of things, to where we can have logical conversations between whether or not something exists, but how to defeat something. And so I think that's what we're suffering right now.
I think one of the biggest annoying things is that people not believing in science now. You never seen these people at like high school and stuff learning about different like scientific aspects and just going, "No, I don't believe any of this."
So I don't think that's necessarily true. I think that these skeptics have been around. These people that don't trust science have been around for a long time. There's many, you can listen to Isaac Asimov or even Carl Sagan talking about it. What I think is that because we have these very powerful social media platforms, is that misinformation can travel very, very quickly. Yeah. And the algorithms can actually, they promote some of this negative stuff. And so I think it's it's obviously not at my level, but I think we need to rethink about how to filter misinformation better. Because the most information travels faster and infects faster than this virus that we work on, right?
Yeah.
This is sort of I don't want to say dumb question, because it's not a dumb question, but it's like nothing to do with the reason we've got you on the podcast. This is just my own personal curiosity about the level of science that you work at. Do you happen to know of people that are studying your level of science, but maybe in a different science, like physics or chemistry or something, that have anti-science beliefs in different fields?
Oh, that's a good question. I have not personally experienced this, but there are, kind of classical examples. There was the one professor, I believe at Berkeley, who thought that HIV didn't cause AIDS. So these people do exist. They can tend to be damaging. One of the classic examples that started the whole anti-vaxxer craze was this physician named Andrew Wakefield, who wrote a paper in Lancet that said that the MMR vaccine caused autism. However, it was later shown, definitively that he cherry-picked his data and made up data, and he had a corporate interest in order to make another vaccine to replace MMR, because MMR is one of the most effective vaccines we've ever had, the safest. And time and time again, we've shown through science that MMR is very, very safe. However, the idea that vaccine causes autism still exists, and so it's very hard to curtail that idea, even with a mountain of evidence. And a lot of this has to do with various biases that we all have learned about, confirmation bias, all this type of stuff. So again, it goes back to my original hypothesis, is that we have to get scientific information into people's heads as soon as they can handle it, starting at grade school and really working on making robust scientific and engineering and STEM very, very early on. Because I think a nation that invests in STEM is a nation that will succeed.
I wonder if this. I wonder with this outbreak. I wonder if there's like a worthwhile time of teaching like biology students and stuff, like a wee bits, like small amounts about like the dangers of viruses and stuff like that. I wonder if that's a worthwhile thing going at like high schools and stuff.
I think so, but I wish we could do it before something major happens.
Yeah.
Right? We need to be able to educate people generally of science very, very early on, so where we can have more substantial debate on whether or not they exist, or whether it hurts my pre-existing beliefs, but more on the fact that, we have this deadly virus out there. We need to wear masks. We need to wash hands. We need to stay away. We need to distance, and that we should be caring for people and being compassionate to people, more so than the irritation of wearing a mask or not being able to go outside. And I think we need to have that mindset, at least in the United States and other places. We have we need to be able to get that across to people.
Mm-hmm. So
should we get into the actual virology questions?
I think so. Aye.
Sure.
So you got somewhere you want to specifically start?
Yeah, I want to start at sort of the basics. So
where did it come from? Should we start right from there?
Yeah, start there. Right.
Well, for sure,
how it came about.
It came from. So for sure, SARS-like viruses. These are beta coronaviruses. They came from bats. All the phylogenetic and evolutionary information suggests they came from bats, and even looking at Bayesian analysis, this strain likely has been in the body of a bat for upwards of 50 years. So it was naturally occurring in a bat, in the body of a bat. How it got transferred from the bat to the human is unknown. That is still the missing piece, and there's been a lot of debate on whether, in the case of SARS-1, we had a person who had gotten it, we believe, from a civet, which is a kind of small rodent-like, raccoon-like creature that is farmed and raised and even caught wild in China in kind of the wild game markets they have in China. And the virus that was from the civet was very similar to the one that was in the person. And so the thought was it went from a bat to a civet to a person. However, we're not sure because this could be an event of convergent evolution where the man got it from the bat first, gave it to the civet, or the civet gave it to the man. And so we're not 100% sure on SARS-1.
Right.
Also, MERS is the Middle Eastern respiratory virus that was found in kind of 2009, I believe. And it seems to have jumped from a bat to a camel to a person. So at least with that lineage of coronavirus, it seems that you need a mixing host. So a host where the bat virus jumps into another host that's mammalian, and then it learns how to infect a more complicated mammalian cell, and then it can transfer onto humans. But it's not so clear between SARS-1 and SARS-2. The closest relative of SARS-2 is also from a bat, but it's only 96% similar, right, on a genetic level. And we found this virus as well in pangolins and minks, and the pangolin viruses are only 91% similar, so it's unlikely that it went from a bat to a pangolin to a human. And so that was the original hypothesis. And so it could be very well that these viruses just jump into organisms very, very quickly. I mean, we can see that a human can give it to something as complicated as a tiger or a gorilla, or dogs. A lot of the president's Secret Service dogs had gotten COVID from Secret Servicemen. It could be that it is a direct bat-to-human transmission. However, we may not ever know. And so that, for sure, this is a virus that, has found a reservoir in bats. And then it's somehow, because it's zoonotic, has transferred from bats to humans.
SARS-1 is what people would know as a SARS outbreak, and then SARS-2 would be COVID-19, right?
That's correct.
Okay.
Yeah.
Right. Yeah. Just for people listening.
So they both stand for severe acute respiratory syndrome. That's what SARS stands for. So when you hear the SARS outbreak, you think of 2002, 2004 right in there, right? Actually, I think it was 2002 is when it was identified. And then when you think of SARS-2, which is SARS-CoV-2, that is the virus, the name of the virus, and the virus obviously in SARS is SARS-CoV-1 now because we found two different versions.
Yeah.
That's the original, and then the disease is coronavirus viral disease 19, so 2019. They're not separate things. Mm-hmm. You hear a lot of people say, "Oh, they're different things," and there's COVID-20 and all this stuff, and that's not true.
It's all these different mutations and stuff that you keep hearing about as well. Like,
can I ask a question before we go on to that? So, just to deal with a conspiracy theory real quick, how do we know that COVID-19 wasn't created by the Chinese government or whoever it is that they've decided?
Has that been decided, the conspiracy theory of like who actually made it yet?
They'll have different Illuminati, Chinese government, whoever,
Freemasons,
whoever they decide is important.
Someone actually suggested to me that the NHS have something to do with this as well.
Because they like being busy.
Because they like being skint. I don't know why, but
they love it. They love having no money. They love struggling.
So I'll answer this in two different ways. Okay. I think one of your co-patriots, John Oliver, did a really good job of this on Last Week and Tonight. And conspiracy theories fill holes into uncertain situations. Yeah. So what do I mean by that? So when you have an uncertain situation, people gravitate to conspiracy theories because it basically allows them to gain control of an uncontrollable situation. Yeah. But the reality is that many things are completely uncontrolled and completely unknown. But by saying, one of these, absurd conspiracy theories, it allows that uncontrollable information that uncontrollable thing to gain control. And so I think that's why people gravitate to these things, and it's unfortunate, but we need to help people again cope with the unknown unknowns better. Yeah. And then again, I think I'm a huge proponent of education and allowing people to, not believe in the phantoms and the ghosts of the past because they're not really there, right? Yeah. And unless you have evidence, true evidence, it doesn't exist. And so Carl Sagan does a very good job in fact checking, and you can go online and read how it has a method actually to fact check pseudoscience and conspiracy theories, and it works still to this day. And so the second part is, how do we know? Well, the natural isolates that we have with the variants of the stuff we sequence look like viruses that we see in nature. And so normally when you engineer something, you would have some bit of it that would show you that it has a piece of a vector or a piece of nucleic acid that is different or shouldn't be there. And so for all intents and purposes, there's a brilliant paper in Nature called The Proximal Origin of SARS-CoV-2. And it's really great. And there is just no evidence for any kind of genetic manipulation of this virus that led to SARS-CoV-2. And it is very unlikely. And to do something de novo, where you basically use a computer to design a virus, is just impossible with our current technology. It's absolutely impossible.
I think
so. Then the people will ask, hey, well, did they take something like SARS-1 and change it or mutate it to look a certain way to make it more deadly? And the answer is just no. There's just no. And there's just so much evidence, and it's just, you have to follow Occam's razor.
Yeah.
When you have so much evidence showing one direction, you have to reject the other information.
Yeah.
You just have to. You have to reject these conspiracy theories.
I think somebody likened it to like a jigsaw puzzle. Probably in the most basic sense, they likened the virus to like a jigsaw puzzle. If you had to go and check on these things, and the shapes weren't in like the perfect way, or they were like somehow like out of shape and stuff like that, that is how you would tell certain things have happened. Yeah, I probably explained that terribly, but.
So, and the question then, being a synthetic biologist, is can we make viruses in a lab? Yes, absolutely. Absolutely. We can make clones of viruses, but we're not building it from scratch.
Yeah.
That's just not possible. Nature invents these things. It does a pretty good job. Way better.
Yeah, it's pretty good.
It's had 4 billion years of evolution to get it right.
Yeah.
Whereas, once we have a sequence, for example, we can build it from nucleic acids and stuff like that. But that's not the case here with SARS-CoV-2. This was a naturally occurring bat virus.
Mm-hmm. I don't understand the obsession with conspiracy theorists of making the person in their conspiracy theory way more powerful than they actually are. Like the 9/11 conspiracy theory, which unfortunately I fell for when I was a teenager, gives George Bush especially way more credit.
A man that struggled to get a quote on during Donald Trump's inauguration.
Yeah.
I guess, like it goes back to what I said before, is that these conspiracies, people gravitate to them because they give answers to an uncontrollable and unknowable situation.
Yeah.
They confirm biases, right? That's the other one.
Yeah.
And they confirm predetermined beliefs. And then, that it's this agency or that agency that's out to hurt me or do whatever. And then the other one is kind of a more interesting one, is this new effect, like the Dunning-Kruger effect, where it's like you don't know what you don't know, right? And everybody falls into this. It's not just, conspiracy theorists. And I think, at least in the U.S., there has been times where, certain things were kept from the public to be found out later to be true. And so I think that triggers that type of feeling sometimes. But at the end of the day, what we have to do is we have to educate better. And we have to communicate science better. Carl Sagan and Neil deGrasse and a lot of these other folks, like, Dr. Cat and potentially even myself, we have to get the idea of critical thinking and being able to think if that is correct or not, and be able to, which is a harder thing for certain people, is to reject our predisposed beliefs.
Yep. If
there's data or evidence that says that you are wrong, you have to accept it. You have to accept it, and it's okay. It's okay if you're wrong. And I think we have this thing where if I'm wrong, I don't have value, or I don't have this, or I don't have that. But I really think that people just have to say, just say a person is wrong, and yeah, sure, it's wrong. Mm-hmm. Obviously there's other things that you shouldn't be doing, like being racist or all these other things. Yeah. But if you're wrong in your scientific assumptions, it's okay.
Yeah.
Right? That's how we progress, is that you reject your predisposed notion, and then you find new hypotheses, which allow you and society as a whole to move forward.
Well, that's one of the things I enjoy most about life, is being sort of blindsided with like new information. That's one of the things that sort of like keep me going a lot of the time.
It fascinates me about science as well, because it's, I mean, you didn't really get it in politics where people accept they're wrong.
Yeah,
it's more in science.
Mm-hmm.
I guess the other thing is that we have so much information. That is absolutely true.
Yeah.
We have so many apps. We have a device that in our hand that basically in the 1980s you would have, godlike potential, right? You have almost all knowledge at the hands at your fingertips, right? And so, how do we? I think it comes back to potentially regulating and potentially having solutions that tackle misinformation. I think we have to get ahead of it now, because if we don't stop it now, we could have, dire consequences. I mean, the attack on our capital is a perfect example of how misinformation can trigger events.
Yeah.
So we have to get our handle on this information.
So did you have?
No.
Sorry, right. Okay. So what should we move on to next? I think.
So what? But before we ask some of these questions, what is your expertise on the vaccine?
On the vaccine, I have never developed a vaccine. However, I understand adaptive innate immunity in viruses and how you would develop a vaccine. We also have I have lots of friends who develop vaccines in their career, but I am not a vaccine expert per se.
Okay, right. Okay. The questions that have been asked should be easy enough to answer for you, not for me, but like for you, for the level of knowledge you have in this situation. I don't think there'll be anything asked where you'd feel uncomfortable answering it. So it should be fine. So should we go on to some of the strains of COVID that have came out? The one that was apparently found in the UK and the Brazilian variant. Do you know much about these? Do you know sort of the differences?
Yeah.
That one, we've been told, could possibly be 30%
more dangerous.
Am I right? I don't want to say the wrong thing. 30% more higher mortality from that one.
Right. So this is what's been suggested. There has been a Trivanad paper that the government of the British government has put out.
Yeah.
There's not a lot of real data in that paper, and so I'm not so sure. There was some thoughts that, if you look at 60-year-olds, that it was like 13 to 10. I'm going to hold off on saying that it's more deadly. However, there is a decent amount of information from its mutation spectrum in the S protein to suggest it could be more contagious.
Okay.
So I would say, go ahead.
How does a virus become more contagious? What does that actually mean?
Yeah, so this is a great question. So this occurs on a molecular level. So the virus is coated with a protein called a spike protein. So it looks like a little ball with pins in it, right? And so the spike proteins are the pins. And so the pins have to then enter the cell. They enter kind of the bloodstream or the nasal passages, and then they have this receptor that then binds this thing called the ACE2 receptor on the surface of the cell. Before that, there is two cleavage events that actually the protein has to be cleaved in a certain way in order for the virus to attach to the receptor and then enter its target cell. The S protein is like a key, right? So you have a key, and then the door and the lock is the cell. And so it has to use its key in order to in order to open the door and infect and kill and replicate in that cell. So when you have mutations in that S protein that allow it to bind tighter or stick on the surface of a cell better, or adhere better, or slip, allowing the virus to move more dynamically through diffusion to inject its basically wrapped nucleic acid around nucleocapsid and shell into the cell. That allows it to be more contagious because it's able to hold on to its target cell or even infect more cells. And so that's how mutation, a natural process in RNA viruses, allow it to become more contagious. Now, viruses, we think of them as like one thing. We think even this B117 variant as one thing. It is not. You are infected with a population of viruses. So you might, and when we sequence these things, we're looking at the most abundant viruses, the most abundant genetic information. Now, there are, small variations within that population. You're basically infected with a city, right? And so if one of those members of that population becomes better at, in replicating itself, it can overtake a variation in a single person and become a new variant. And then it has to spread on a population level. So mutation is just part of evolution. It's just part of natural change. This one has a proofreading enzyme, which allows it to be more stable and less, it'll have a less mutation spectrum than something like HIV, for example. But that mutation is, it's this process of random mutation and selection. So if you had, a bin and a rubber ball, and the rubber ball was trying to bounce itself into the bin, right? If the rubber ball was more sticky, and it would stick to the bin better when you threw it, then you would want more of those sticky balls to throw into the bin, right? And this is the exact way that mutation and evolution work.
This is perfectly explaining viruses to us. Sticky balls and bins. Perfect.
So, if you had these bins and you were throwing, different balls into the bins, you would want, if a ball, 9 out of 10 goes into that bin better, you'd want that ball, right? And so that's how evolution works. Is that it's this random chance and it's random in its way to find the best candidate. Mm-hmm. If the ball if you had a ball that every time you threw it into the bin it bounced out, you're not going to want to use that ball anymore. So that's how evolution works. So that one that was sticky, that would stick to the bottom of the bin, would be a ball that would be more successful. It would be able, let's say this ball can replicate itself, and then it replicates itself in the bin, and then you would have more of these balls in the bin. Mm-hmm. So, just an example.
You said you were a professor, right?
Yes, I am.
Perfect. I've never had that explained so well that I actually understand it. Yeah. Normally I just say yes and pretend that I kind of get it.
Yeah.
But that was amazing. Well done.
Well, thank you. I appreciate that. I try to be a good scientific communicator. I follow Carl Sagan and Neil deGrasse, and I focus on trying to explain it, because if I can't explain it to anybody, then I'm not explaining it correctly.
Yeah.
Yeah.
Right. And so, and that goes back to my original thesis statement of this whole conversation, is that we have to be better at communicating complex processes to everyone, and so that they can become more educated, and they can come out and ask more questions, and they can learn. Because I think that the only way to defeat ignorance is through education and through knowledge. And I think knowledge can cut through ignorance like a knife through hot butter. But we have to give people the butter knife in order to go through that hot butter, and that is through knowledge.
Yeah.
So the Brazilian variant, I had a coughing fit. Have we talked about that yet?
We have not.
Okay, I had a coughing fit, so I had to leave. So I missed part of it. I only caught you at the end of that there. So the Brazilian variant, is that more contagious as well, or is that more deadly, or is it pretty much the same?
We don't know as much about the Brazilian variant. There has been a paper that has pushed out. It does have several mutations of biological importance, such as the N501Y, the E485K. It's been identified. It's been found. It was originally found in Brazil, but it's now in Japan and other areas. But we don't know enough about its pathogenicity yet. It is a separate lineage off the B1128, which we have found, elsewhere. And so we don't really have, these things are happening very, very fast. We know this variant exists. We know where to place it in kind of an evolutionary history and kind of the evolution of the virus, but we do not know enough about its pathogenicity or contagiousness yet. And anyone that says they know everything about it probably doesn't. So we just, and these things that we have a lot now is we put these things out in preprint, which is good. It disseminates the information, but the preprint, which is not peer-reviewed, tends to not get all the details down. And the news media then takes it as status quo, and it's not necessarily been validated yet. So, the dominant one that we see all over the world is this variant called B6114G. And that's kind of the dominant variant that we're seeing. Obviously we've evolved in this new strain, this B117, which this American CDC say could be the dominant variant by March. I hope not. And if we hope, and we know that the vaccine, at least the Pfizer vaccine, has been tested against the B117, and it's shown to be potentially effective against it. Again, this is preprint. It does need to go through peer review. The P1 is potentially worrisome because it has the one mutation, N501Y, which allows for make it more contagious, can bind the cells better. That we also see in the South African variant. And as been said, that it's 50% more transmissible, the B117. Okay. The worry is that both the South African and the P1 variant have the E484K, which is a variant in the S protein, which allows the escape of monoclonal antibodies. So what does that mean? So again, this is the pin, the key, if you will, that opens the door to the cell, and that variant basically allows that where the antibody that normally would bind to it and block it from entering the door, that mutation allows escape, so that it can actually open the door still. And so, in the case of monoclonals that have been tested and serum that have been tested from patients with natural infection. Now, we don't know whether, because when you make a vaccine to the S protein, like in the case of the mRNA vaccine, as well as the Oxford vaccine, which, from a single protein, we assume that you get more diversity of antibody response, and that this escape mutation may not be as problematic, but more testing needs to be done.
Mm-hmm. Again, covered perfectly.
Yeah,
that's awesome.
I like that mutations also get names. I don't know if that's mutations that already exist, and it's like a well,
that's a good point.
Utility belt, it's specific things that you need, and then you've just gave them a name, and then that mutation happens in specific viruses, or whether they've found a specific thing in a virus and decided to name it.
So it goes. So they tested the vaccine in trials, and I think there was a PNAS paper, Proceedings of the National Academy of Sciences, where they tested a lot of these variants against the vaccine, and back in August. Now some of these new variants have multiple mutations on top, but they tested single variants and showed that it was effective. And I, again, it's my belief, but this may come to haunt me later on this podcast, is that I, trust that the current vaccines, if we get them into the bodies of people with 2 doses as soon as possible, that the numbers will drop so dramatically that these new variants won't be a problem. As well, Merck was also doing a vaccine trial. They had recently, it had recently failed. It's more of a traditional approach where you have a deactivated virus and it didn't really work. However, they are working on multiple antivirals. And so part of my group is to build new antivirals. We have whole classes of drugs for antibiotics, whole classes, that target all these different things. In HIV, we defeated HIV. We're defeating HIV. We haven't defeated it completely. Hopefully, eventually we will. We've defeated HIV by antivirals. We've attacked that virus through this thing called highly active retroviral therapy, where we attack every part of the virus. We should do the same for coronavirus and flu. And we should be in the business of eradicating viruses, eradicating disease. We've only eradicated 2 viruses in the history of the world, and that was smallpox back in 1980. But that took a global response. Everyone got vaccinated. We eliminated it. Most of the people that were born, one of these people, had never seen smallpox. Smallpox, in the last decade of its existence, killed over 300 million people.
Jeez.
Right? Okay. We are lucky that my generation, past 1980, have never seen this virus. This virus had been around for at least 5,000 years, potentially longer. And so we've only eradicated one. The other one we eradicated was this thing called cow measles. It was basically a paramyxovirus that infects cows, and it's called rinderpest, and that is gone. It's been eradicated. But we're very close to eradicating polio. This virus that no natural polio has been found in Africa. There is the vaccine-derived polio, which can kind of reanimate itself and infect people, but natural polio they believe to be extinct in Africa. However, we need to. It is reservoired in other places, and so we need to eradicate it. And I think that if we had antivirals, and we only have like about 5 that I can name off the top of my head. We have remdesivir, Tamiflu, all these kinds of things. And so we need to have whole drug classes of antivirals. And I think that's where synthetic biology can come in, is that we build synthetic molecules or proteins. There's a lot of these antibody type drugs like Abcella out of British Columbia that are actually making monoclonal antibody blends to actually go after these viruses. But I think we need to be careful, obviously, with these things because it could potentially create resistance, and so we need to attack viruses at all parts of their replication cycle. Remdesivir actually it was originally worked out for Ebola, and now has been moved to it actually has multiple inhibiting effects of the RNA-dependent RNA polymerase. You're like, well, what is that? So that is the protein that the virus encodes in order to replicate itself. So it has to have that protein. If it doesn't have that protein, it doesn't replicate itself. The most benefit is that the host doesn't make that protein. So you have very little, at least not the viral version. You have very little of that protein. That protein is very specific and it's a great target. So we should be tackling that. We should be tackling the fusion of the virus. And so we should be attacking the virus with all these different antivirals. And we should be in the process of where we have these antivirals online, and then that gives us time to build a vaccine, and then we can wipe it off the face of the planet. I would love to have a trophy room of all the dead viruses and pathogens we've eradicated from this planet.
That would definitely be incredible.
And we have to do something. And so another part of my lab that we're focusing on now is the sleeping giant pandemic, and that is multi-drug resistant organisms in mainly bacteria, but they're also fungi as well, mainly in plants. I lost my own mother to a multi-drug resistant organism. The WHO predicts that over 10 million people a year will die by 2050 from multi-drug resistant organisms. There is a new type of, I believe, gonorrhea that is completely multi-drug resistant. It has you get this gonorrhea, there is no antibiotic we can give you. Nothing. So the idea that people are starting to think about is an old idea, which is taking a virus that kills bacteria, known as a bacteriophage, to actually go off and kill these multi-drug resistant bacteria. And so I think that we will see, because of synthetic biology and because of synthetic virology, this idea of going into natural ecosystem, finding viruses, modifying them to kill multi-drug resistant bacteria. And these
Yes.
viruses, these bacteriophage, there's more bacteriophage in your mouth than there are stars in the Milky Way galaxy. So we have a tremendous library of viral material that we can use computationally and synthetically to eliminate something like Staph aureus or MRSA from causing multi-drug resistant disease in people. And so we can use a virus to kill another pathogen that basically is our friend. The reason we even breathe today is that there's a good portion of, it's a significant but not huge amount of portion of our oxygen that is virally mediated. There's a virus that infects cyanobacteria. These are like blue-green algae is what they used to be called in the ocean. And it infects the cyanobacteria. It cranks up primary productivity through its own viral photosystem, its own photosynthetic machinery, in order to make new nucleic acids. So there could be a portion of the oxygen that we breathe that is viral in origin. So,
Nice.
Yeah.
I love the fact that
It's worth knowing about these things, to be fair. It
Yeah.
is.
no, I cannot believe in such a small amount of time there's so many things that I had no idea existed.
As 3 minutes has passed and you've been completely schooled.
Yeah, I mean 1,000 things that I didn't know existed are in my head now.
Well, so put it in perspective, like the availability of how I think, we had phage point 1. So phage point 1.0 was, led to sequencing. It led to innovations in next-gen sequencing that led to the completion of the human genome. And that all started at phage. If you look at Luria and Fleming back in the day of antibiotics, Luria predicted, a phage biologist, a T4 phage biologist, predicted all of the antibiotics. And there's back and forth in the 1930s, going back and forth. And within 2 years of releasing penicillin, you had resistant penicillin, or you had organisms that were resistant to penicillin. And the reason for that is that the antibiotics are bactericidal. They're bacteriostatic, not bactericidal. So they don't kill all the way a lot of the time. And so some escape. And because they escape, they can evolve to withstand that antibiotic, right? And Julian Davies' work at a UBC, he was in my department when I did my PhD. I spent his whole career, I think over 50 years, looking at when I take an antibiotic, sub-inhibitory amounts of that antibiotic go through my metabolism and then go back out into wastewater streams. And then those wastewater streams can get back into the environment and then basically vaccinate bacteria against these things that we use to defeat them. But we need to not wait. There was a paper back in 2007 that basically said that, the spillover and the potential of a pandemic SARS-like virus is very high. And it's a time bomb. That's what they described it back in 2007. Here we are today, here in 2021, where over 400,000 Americans have passed away from COVID-19. That's more than the entire U.S. casualty death of 4 years of World War II in the course of a year, from the first case that happened back in January 21st, 2020. We cannot wait with multi-drug resistant organisms. We cannot wait to control flu, which has also major pandemic potential. We cannot wait until something out of the measles family comes, something like Nipah virus become a pandemic virus, and we cannot wait on climate change anymore. We cannot. We must invest broadly in all of these things. Because every species, I've studied the origin of life with viruses and stuff like microbial mats and stromatolites, and most species don't make it. Like they just don't through time. If you look at 4 billion years of evolution, most species don't make it, right? And so we are on the precipice of an abyss if we do not invest broadly in STEM and mitigation factors. And not only that these factors will boost our economy and all global economy.
Yeah.
At one point, NASA had 11% of the federal budget during the space race. And what came of that? The internet, cell phone technology, computers, the thing we're talking on today, all products of the space race. And so again, it comes back to investing broadly in our scientists, and broadly in our engineers, our mathematicians, as well acknowledging the people that are, that make our daily life possible. the essential workers, as we call them, giving them, a path towards a reasonable life.
Yeah.
So, yeah.
Definitely, man. I think you've covered pretty much everything there.
Yeah.
Awesome.
Should we cover some of the questions that we've got?
Yeah. Before we let you go, Richard, we have a few questions from people. If that's okay to go through them.
I think they're mostly
Sure. No,
vaccine
absolutely.
based.
Yeah, that's what I'm here for.
Awesome, man.
Yeah.
Awesome.
Do you want to go? I'm
Go
not
with
on my
this
phone.
question.
All right. Well, I'll go first. I have a question here from Claire Mack. I want to know if studies show all blood types are less affected, with lesser effects than others, especially rhesus negatives.
Yeah. So this one comes up a lot, and so this comes from a paper that was published about O versus A blood types.
Yeah.
Now there is a correlation between, and there's a positive correlation between type O positive versus A or B or vice versa. Now this is a correlation that basically points to either disease severity or changes in the disease. Now, we don't have a biochemical mechanism on how that would work. And so, personally, the jury is still out, because you can have correlation that really doesn't mean anything, right? And so we need a mechanism on why that would be. Why if you had a different, if you were O or A, why you would have a different outcome with something like COVID-19. And I'm going to think in the future that it probably is not going to be anything. But it doesn't matter. That's my thing. But the jury is still out.
Okay.
I have a question from Francesca, and she's
Sure.
asking sort of a two-parter question. It's about the effect of the new COVID vaccines on fertility of women, and sort of how it will affect birth control, and if that could be long term. She's specifically worried because of the thalidomide issue.
So this one has come up again as another false thing that the vaccine causes infertility issues and stuff like this. This is all complete nonsense. There is no evidence that any vaccine causes infertility. And most treatments for, making someone, you have tubal ligation or you have vasectomies is a surgery, right? So if there was any pill or vaccine or shot that would give you, would not allow you to get pregnant, that would be a decent thing, right? Because normally the practice is done through surgery. But there is no evidence that any vaccine causes any kind of issue with fertility.
Okay.
So that's a blatant no.
Okay.
Comes down around a lot. There's a pseudoscience thing out there with anti-vaxxers saying that it's like a reverse retrovirus. It's just all kinds of nonsense, but it's nonsense.
Okay. I'll go now.
How many have you got?
3.
Okay, right.
I'll just do this one.
Yeah.
Okay, this is from Lauren Jones. This is a bit of a long one. I'll try and do it quickly. I caught COVID at the end of December, and it recently came out on the news that they reckon I'll have around 85% immunity for 5 months, but can still carry and transmit the virus. As I understand it, this is where I'm possibly wrong. The vaccine works by priming the body to recognise the protein in the virus so it can fight it off quicker. I think that's how immunity works after you've had the virus as well. So will the vaccine only work for 5 months as well? I realise the answer to this is probably no, but I'd be keen to understand why.
So, what is interesting about these viruses is that natural infection doesn't give you a lot of immunity.
Okay.
At least that's the thought. Now, it goes back and forth, but we need more study on this. Whether natural immunity, because there's very good documented cases where a person had gotten one strain of COVID and 3 or 4 months later, well, actually SARS-CoV-2, not COVID, they got COVID, but they got one strain of SARS-CoV-2, and then a couple months later, they got reinfected with another virus. It's similar. It's the same. They're small differences between the two, but they got reinfected. And so, as far as the vaccine is concerned, we all need to get it as soon as possible. And then the second thing is we need more data on whether the vaccine protects you not only from infection, but also from transmission. And so the thought is that it should, but we need hard data in order to confirm that. And so the general hypothesis is that if I have a strong adaptive immune response and I'm able to inhibit the virus where it doesn't really replicate, where I don't have symptoms, or it's so low, right, that I don't make a lot of virus, right? And so if I don't make a lot of virus, the ability for that virus to transfer is very, very low. But we need hard data to show that one way or the other. And so to answer two things, no effective on fertility at all. And then second, the jury is still out on whether you can get infected with the vaccine and transfer it to others. And the hypothesis is theoretically yes, but if you need a certain amount, and this is the other thing, in order to have a robust infection with this virus, you need a certain number of viruses that infect you. Like if you get infected with 5, probably not going to get sick. Now, if you get infected with 10 billion of them, or 100 billion of them, when someone sneezes on you, then you have a good chance of getting it. Will the protection or the vaccine protect you from something like that happening? Absolutely. Mm-hmm. Now, if you have a mask on, you wash your hands, you're wearing your PPE, if you're wearing like goggles or a face mask or vice versa, and you're vaccinating, the likelihood of you giving it to someone else is basically it's close to zero.
The funny thing was
that's why. Go ahead.
Sorry, that is the first time I've actually had. Like I've heard a lot of people talking about when it gets transferred, you're putting in the air a few droplets, like a bunch of droplets, but I heard 10 billion there. So there's 100 billion sort of thing. So that's the first time I've heard the number actually come from somebody.
Right. Someone that's infected is making, and they can be completely asymptomatic.
Yeah.
Right, where there's no real symptoms because there's something inherent in their genes or microbiome for that matter, the bacteria and viruses live in their body that make it to where they don't have symptoms. And there are people that probably walking around right now today that are 100% resistant. This happens in every pathogen. The classic example of this is the Romani people with the Black Death or the Yersinia pestis, where they are a large portion of them are naturally resistant to the Black Death, but they make no adaptive immune response. And vaccination for Yersinia pestis, making a vaccine for Yersinia pestis, is basically failed. The mutation that the Romani people have activates the innate immune system through toll-like receptors that recognize the Yersinia pestis gram-negative bacteria faster, so it allows for your innate immune system to overwhelm it and defeat it before it becomes a reservoir in their body. And there are, without a doubt, people out there, we don't know this yet, that will have natural resistance to this virus. And part of what we're doing now is trying to figure that out and why they have natural resistance. Because even people with HIV, there are other people that are elite suppressors, and there's a common example of this is there's this delta 32 deletion of the co-receptor, and if they are homozygous, they are partially resistant to HIV. So we will find these mutations and naturally occurring in people. The host, this process called Red Queen, for both the virus and the human and the host. In our case, the human and virus have to evolve at the same rate, otherwise they both cease to exist. And so they evolve. So the minute a virus comes up with a new variant, the host will also come up with a way to defeat it. It's the natural course of evolution.
Okay.
This one's from Ron. In their typical workday, do they need to spend much of their time debating the value of their work and the veracity of vaccines?
I don't really know how to answer that one. Say that one again.
Do you spend a lot of your day having to defend how effective vaccines are, basically?
Not a lot, but I do spend a little time on it every day. Yes, I do. I mean, I think a lot of us out there are in the scientific community are having to dispel pseudoscience and misinformation. I think it's become part of our ethos now.
That's very sad.
That is very sad, definitely. We have a question here from Steve Chalmers. Can you ask him if you've if you've already had COVID and are now apparently immune, why would you need the vaccine, and what protects you more, catching the virus or getting the vaccine?
Vaccine, 100%.
Yeah. Go.
Next question.
Sounds really easy. And so, natural infection, and there's potentially probably a Nobel Prize in there somewhere about how these viruses mess with the immune system, and how that we don't gain memory potentially from natural infection. And that goes to a lot of these viruses that were even flu. Like, how do you not gain, why do we have to take a vaccine every couple of months, every year? It's because the virus mutates out of an effective vaccine. And so we have to take and that vaccine for that year works perfect on those variants and those strains, right?
Yeah. But
then the next year, because these things mix in birds and animals, and you get recombination and small mutations, that we need a slightly different vaccine cocktail. Now with the new mRNA cocktails and new technologies that we've developed in COVID-19, I think that we might get to a point where we might have a universal flu spec from this. And if you've noticed, by wearing masks and washing your hands and social distancing, our flu has gone down massively.
Yeah.
And so I hope we normalize, at least in the United States, maybe in Europe as well, is that if you feel sick, stay home, right? If you can. And then if you have to go to work and you feel sick, wear a mask.
Yeah,
I'm quite happy to continue that
Asia
on.
does this very well. Asia, like in Japan and, China, and when they feel sick, they wear masks.
Yeah.
Or they stay home. And, I wonder now, even when when I caught the flu, and I tried to stay home as much, but there was a time where I would go to work, and I regret that I should have stayed home, or I should have worn a mask.
Yeah, I've done it a few times myself.
I think we all have, and I think this has been a thing that I hope we normalize. Washing hands, not shaking hands. I like the elbow bump. That's kind of the Roman way they used to do it.
It looks cool now.
Yeah, it looks cool.
Yeah, you bump elbows instead of shaking hands.
Yeah.
And we should be, if you're sick, stay home if you can. And we need to, I think it is also really open the eyes of people that there's a lot of people that are really essential to keep things going, and we should give them a wage that they can live on.
Yes.
What's been great?
Absolutely. Minimum wage shop workers especially.
Yeah, definitely. You know what?
Dismissed all the time for not having a real job, or for not. I'm smarter than you because I've got a college degree. You're just working in a shop.
You see,
that sort of stuff.
We have to also normalize the culture there too. Because when I was growing up, everybody smoked, right? Everybody smoked cigarettes. Everybody, had chewing tobacco and all that. I don't see anybody doing that now. And we didn't really necessarily ban cigarettes. What we did is we changed the culture.
Yeah.
And we said, oh, it's gross. It's gross.
Yeah.
Right? Kids nowadays, like my daughter's generation, is like, oh, gross.
Yeah.
And if we do that with, oh, you're sick, you're not wearing a mask, oh, gross.
Yeah.
And you potentially guilt people into doing the right thing, I guess, is what I'm trying to say. And I hope we normalize that behavior of washing our hands, of wearing masks when we're sick, staying home, appreciating the people that work in the service industry.
Mm-hmm.
My wife works in the service industry. She runs a bunch of Starbucks. And the way that people talk down to people in the service industry and industries like that, it's disgusting.
One thing that's
absolutely disgusting.
One thing that's been great to witness is, and this was almost within the first few days of schools getting closed.
Yeah.
Almost within the first few days, there was tons and tons of parents just went,
Teachers
"Oh my God, teachers are amazing."
Yeah.
That took 2 fucking days
Yeah.
just to get that into people's heads. So that was amazing to see.
Again, we suffer with this a lot in the United States, where teachers are taking up 2 or 3 jobs, or they're getting out of it, and we need, again, it goes back, there's this really epic photo from after Hiroshima, and there's a woman on I think on a raft, right, in Japan, and she's teaching kids like the day after, right? And it's just this most amazing, breathtaking, photo of human perseverance, and I think that we need to, maybe, I think, if we, change the culture socially, and we say, look, these people are great and they're essential, so what? They're working at a place that's, they're doing a good thing. They're working, they're doing, and, it's not me better than you. It's we're all in it together, So,
That's it.
That's my thing.
Do you have a final question?
Yeah.
I have a final question for me. That's why I wanted to get you.
I've got 3 left.
Oh shit! Right. Okay.
I think I could skip that one though, because that one's kind of been answered.
Right.
Do you believe that deforestation and the destruction of habitats of bats and possibly other animals has allowed viruses that have been prevalent in them to mutate and be able to affect humans? Or in short, what are your opinions on where this virus... Oh no, we've answered that.
No, we kind of answered that already.
Well, for sure it came from bats.
Yeah.
Do I think that if we encroach on wild populations that there's potential for more zoonotic spillover? Absolutely.
Okay.
Yeah.
Absolutely. And I think we need to figure out and surveil better. And potentially, with the technology we have now, we can sequence the entire microbiota and sample these wild bats and look for, and I mean, this was part of the one NIH program that got kind of politically tied up with our former administration. But we need to surveil these things, and we need to also think about potentially vaccinating wild populations for these things, or surveilling them such that we know and we can forecast such events. But yes, as we encroach on wild habitats and people go into areas that they have not gone before, spillover can happen. This has been known for probably, at least 60 to 70 years. I mean, Marburg, which is a Ebola relative, the folks in Marburg, Germany, were working on primates, and there was blood that was spilled, and someone got sick with Marburg, and they had an outbreak there. They were able to contain it, right?
Yeah.
So it goes back to yes, and we need more. We need to basically find ways to surveil and potentially even, in certain cases, vaccinate wild animals from these diseases.
This one's from Dave. I think his second name is Echo Says, but that just means Scottish and French. So I don't know if that's his real name. Anyway, his question is that he's seen a lot of people making sort of unsubstantiated claims against vaccines and the damage that they're going to do. What are some real theoretical risks of the vaccine, and how probable are they? I think he's probably referring to the new thing about in Norway, I think, 21 people in a care home died.
This one came out. This one's come out. This is one of the newer ones. So as far as hard data, the average vaccine, this is published in 2019, is 1.3 anaphylaxis per 1 million vaccines given. So if you look at kind of the classic MMR vaccine, very, very low side effects, no link to autism. We've nailed that one a million times into the ground, and still people believe it.
Yeah.
It's but there's a lot of stuff like this. It's like this whole thing with like right brain versus left brain. That's all nonsense. Or that you only use 10% of your brain. That's also nonsense.
Yeah, I don't
if you
know
only
why
use 10% of your brain,
obviously nonsense. I don't know why that became a thing.
I mean, if you only use this 10% of your brain, you would evolve the smaller brain, and they would have gotten rid of all the nonsense.
Yeah.
Right? Smaller head. Right?
All the extra meat just fucking disappeared. The rest of the meat.
Yeah, that would have gotten cut out probably.
Yeah.
Or like, more, there's all kinds of this stuff that just holds on, like, that people are more violent under a full moon. Like, it's just nonsense. Just nonsense. And we have to
That's
you
where
know,
the
or
bull- the
like,
bull thing
you know,
comes from.
full moons make people more, you know, hostile or freak or more weird or, you know, some nonsense like that, you know. But it's all nonsense. And that's how pseudoscience works. It's just, it's kind of like a chainmail. It kind of builds on itself. So as far as this thing, there was 23 individuals in Norway that had received the vaccine that died. However, we don't know if that's due to the vaccine or due to their pre-existing condition, because they were over the age of, I believe, 75, and that potential group, they lose over 400 people a week just to, you know, their current medical condition.
Yeah.
So it's unknown whether the vaccine caused aggravation of their, you know, current state or disease state they were currently in. This vaccine, both the MMR vaccine and both COVID, both the AstraZeneca, both the mRNA vaccines are very, very safe. And then with anaphylaxis, we can treat it. Actually, you're more likely to have anaphylaxis from penicillin than you are from this vaccine. So again, there is this group of people that they are biased, and no matter how much evidence you give them because of their extreme confirmation bias, no matter how much you throw at them, even though we've shown time and time again that Andrew Wakefield is wrong. I mean, and then there are scientists that are grifters that make money out of this. I mean, Andrew Wakefield still goes out and gives seminars about how terrible the MMR vaccine, and he writes books on. So there are these kind of professional grifters that do that, right? And we need to stop them from this because misinformation can get people hurt. And you know, again, going back to what happened on January 6th, 5 people died from misinformation. Definitively.
So this is the final question, and I was thinking of not asking it because it's specific to what's happening here, and more specifically with Boris Johnson. But I'm going to ask it anyway, just because it'll be interesting to get your opinion. The English government has stated that it will start to open up within weeks, taking advantage of the vaccine. I presume this means maintaining a high COVID rate. It definitely means pushing up the R for people like me who will not be able to get the vaccine for 9 to 12 months. Any comments on that?
Oh boy. And I may not get lots of love for this, but I think, let's just close it for a bit. We closed it down when there was not, in our case in the United States, we are having upwards of 150,000 cases a day, right? We closed it when there was not even that amount of cases. So why not just, have 2 weeks to maybe as much as 6 weeks to, have people stay home, pay them, make sure their bills are covered. Have them, have them order, stuff off, like Amazon or something like that.
Yeah.
And let's just, where are we just give food or whatever to people and, put, homeless in the right place, where they're taken care of. Yeah. And let's just try to get these numbers down first. Get them down.
What's great is
we are doing that. We done that in March.
Well, that's what's great is we actually discussed doing this because I'm in favour, like as much the same as you are, locking the country completely down. The government have the money to be able to offer somebody like a couple of food vouchers a day.
Cheaper than the alternatives that they have put together.
Yeah.
We're looking at another $1.9 trillion thing now. And the idea behind the shutdowns, and other countries have done really well with this. The U.S. failed in this in spades. But if you look at a place like Taiwan or Iceland or New Zealand, the shutdown was in order to give medical folks and contract tracers time and getting the testing ready to go to where we could test everybody robustly. And Iceland had it down such to a science that they hired detectives to go and trace people, and then they would if they were positive, they were put in quarantine or they were told to stay at home. and then all the new cases that came up were in quarantine, and then it wouldn't spread. Taiwan also did this very, very effectively. Personally, I think if we need to have it robustly funded so people aren't suffering for 2 weeks.
Yeah.
And we have two, at least in the United States, we should have 2 solid weeks of really nothing. You stay at your house 2 weeks. Just to get the numbers down.
Yeah.
The problem that we have in the U.S. is that they don't listen. Right?
Yeah. Same here.
If people were, it's not a big deal, it's not going to affect me, blah, blah, blah. And a lot of the cases that I see is individuals like, well, I'm not a big deal, I'm young, I'm healthy, blah, blah, blah. I just had a mild cold, and then they go home to their parents.
Yeah.
Or their grandparents. And they die from it. I've seen it so many times, as working with the virus and talking to people about it. I just want to go see my grandparents, and then I go see the grandparents, and then they get it, and they're dead. And it's a huge tragedy, absolutely huge tragedy.
Yeah.
I have a final question that probably would have been
Well, I'll have a
better
final
for...
question as well, but you can...
Okay, we have 2 final questions. This probably would have been a better question for Kat, but you're here, so we're going to ask anyway. I don't know how much you know about the situation in the UK at the moment, but right now, according to deaths, we are doing worse than the US. We are like top in the world of terrible. We're getting 1,300 people dead a day, and we've got like a quarter of the population, so we're doing really fucking badly. I don't understand why. The US, I don't think any state, maybe California has a stay-at-home order, a lockdown as we call it, but there's nothing across the board. We've had 3 lockdowns in the UK, more than that possibly. Wales have shut down 3 or 4 times. England has shut down 3 times. This is the second time Scotland has locked down, and we are still doing worse. Why? Why the fuck are we still stuck in this shit?
It's a really good question. Oh boy. The simple answer, Occam's razor, people aren't listening. That's the bottom line. It only takes one person, man. That's the problem. And even if you lock it down and if you don't enforce it, back in like 1918, India is currently, they enforced it pretty heavily, not as much lately, but there'd be parts where there'd be people just come by and give you a ticket. In 1918, if they didn't see you wear a mask, and you didn't wear it properly, they gave you a ticket. And so, again, it falls into the case in the United States. I don't know about UK, but in Scotland, but in the United States, it falls into this weird nebulous, it's my right to not wear a mask.
Yeah, that's happened
like,
here,
no, it's not, because if your right infringes on another person's right, it's really not a right. Right? Yeah. So, and again, what is the root of it? As I've mentioned through the whole thesis statement of this conversation, is that it comes back to education. It comes back to fundamental education and also coping mechanisms. I think if we have people learn to cope better with unpredictable situations and answers that don't know, unless in a state of constant panic and fear, I think, but we all struggle with it, myself included. If we have people learn better coping skills, we also have them be more motivated by the common good instead of wealth driven. Again, a lot of these things I think we have to, like I said in the example with cigarettes, is we have to change the social culture of our society by saying, being a selfish person that doesn't wear a mask is gross.
Yeah.
And you don't want to be like that person, right? And so in the case of your lockdown situation, it is unfortunately the simple answer is people aren't listening.
Yeah.
They're not listening, and if they're not getting any kind of either some sort of penalty, they will continue not to.
But there's been a few,
perfect example.
300 or 400 people, parties shut down, and they've been given £200 or £300 fines. But apart from that, like,
yeah,
nothing on a small scale.
Yeah, I see it all over social media. People they went to Halloween parties,
Yeah.
and they went to, grandparents or people they hadn't seen, and people got sick. The same thing with Thanksgiving. Same thing with Christmas. Same thing with New Year's. I don't know how you convince someone to stay home.
It's annoying because it's the same thing we've constantly been talking about since March, or even before March.
We've been talking about this, and the case that for me, I was already isolating right after the Super Bowl because I knew this was going to be a thing, right, for here. But we should have been wearing masks in the United States back in January.
Yeah,
right? We learned some. And this thing is by far more infectious than any seasonal flu strain we've seen. Period. Because what we're doing to mitigate COVID is actually shutting the seasonal flu down almost completely.
Yeah, they've had 400 flu deaths, and we normally have about 18,000.
Is that since March? 400?
Yeah.
Last year, I don't know what's spreading.
The biggest one we had in the United States, I think, was like 60,000 back in 2017. If you took all the 10 years of flu, we still wouldn't have had what we had with COVID.
Yeah.
Again, we've lost more people. If you combine every war from Korea to Vietnam, all the ones that we've had in the United States, and you include World War I, we've had double the amount of deaths in this year.
I never put that.
If we include just the civil, we passed the Civil War and we passed World War II, which is the most deadliest conflict in the history of the United States and the world, for that matter.
Yeah, we need to get you on Joe Rogan, Richard.
Yes,
this is what we need to happen next.
I would debate him any day of the week.
This would be so good because I'm sick of having. I
will debate anybody you put in front of me. So I'd be more than happy to do that.
Let's go crazy on Twitter, Richard. We'll go fucking crazy on Twitter.
The normal step is everybody Joe Rogan has used to be on our podcast, and so as a general.
Yeah. I'd be more than happy to debate any anti-science, anti-vaxxer any day of the week.
Perfect. Okay, so I had one last question.
I had one more question.
I did. Yeah, and this is. There's no such thing as a silly question.
I had a question, but
okay. My final question was basically, we caught COVID in, would you say, like early October?
Fucking caught my cables. Hang on.
So we managed to both get COVID. We live in the same house. It was kind of obvious that we were going to get it.
Yeah.
Well, at least pass to each other. We knew that was going to happen. But I think we sort of lost our sense of taste and sense of smell and stuff like that as well.
That's heavily. The big one. That's the one that is like that. Now, does it happen in flu and other viruses? Yes, but is it rare? Absolutely. This virus is. If you were gonna, kind of the classic movie from the United States is like Home Alone, where the burglars like steal everything in the house and then they leave the sinks on so it floods the house and they call themselves the wet bandits. This virus, its calling card is the loss of taste and smell. Yeah. That is dead ringer. If you randomly lost your taste and smell, and then that is most likely this virus.
Well, that was, we didn't realize how serious it was, and I'll finish this question quickly. What's happened to me is and I think it has something to do with the COVID, but I have nothing to back this up, so I'm just going to say it and see what it goes. I managed to stop smoking almost like. I think it was a few weeks after I actually lost the sense of taste and everything like that from COVID. I don't know if that has happened to anybody else. I've not heard any stories.
I don't know. That's a good one. Mm-hmm. That's a good one. I have seen. So I'll give you a perfect example. I had a friend who got it, early on and didn't notice anything, right? Mm-hmm. And then his wife made him some very spicy chili because he likes spicy.
Yeah.
And he kept telling his wife, like, it's not spicy enough. Bring him the Tabasco, right? And he pours on more and more Tabasco, and his wife is like, well, your mouth is blistering. right? And he'd realized that he had lost his taste and smell. And some people, they get it back right away, and then other people haven't. And so it has something to do with the reception and disruption of olfactory receptors in the brain when it infects potentially. There is a decent paper that we reviewed a while ago about this, but it's a dead ringer for this virus. And you see like challenges on like TikTok and YouTube where people will do like different drinks, right? And the girl is trying to do drinks and it gets to milk and she's like, oh, it's flavorless, but chalky or flavorless and thick or something like that, and or people like burning an orange, you're supposed to supposedly burn an orange. And if you can't smell that, you're in trouble. And we the other thing that people talk a lot about, which we don't talk enough about, is there are people that recovery isn't recovery, right? A lot of people say, "Oh, you're recovered," right? But recovery can mean everything from double lung transplant to permanent damage of the lung or the kidney, or it's a or blood clotting. The one actor who eventually died from COVID had serious blood clots and had to have one of his limbs removed. And so we will have a generation of people that are without individuals that have perished from this virus. So there'll be a huge bereavement, obviously. The other thing is that there will be people that are permanently disabled from this, unfortunately. And we can't just say, oh, they're recovered and back to normal. And as well, there's a lot of these things like long COVID, where people have symptoms 6 months later. There was a paper that was just published out of China where people had at least one of the symptoms 6 months later. And so this is unlike anything we've seen before, to where you'll have potentially damage downstream, and we need to mitigate that. A lot of it, with what we're working on, is trying to look at the gut microbiota's role in this whole thing. And so if you could, if it's disturbed, the gut microbiota you lead to some other inflammatory state, which causes problems. And so we're trying to think about ways that if that's true, then we can mitigate the dysbiosis by supplementing with probiotics or, phage therapy or something like that. And so that's where we're at.
So annoyingly, I've become like a positive COVID story, which is really irritating to me. Yeah,
what seems to have happened to you is your taste and smell went away, and then it came back hating the taste of cigarettes.
Well, that's because even during when we had COVID, I was starting to go off them at the time, and I knew it was because of the sense of taste and smell at the time. But once the COVID went away, I felt like I got it back a little bit. But it's been 3 months since then, and I just today, sneakily, thought I'd go to the shop and try a cigarette.
Yeah.
And I can't go back. It tastes disgusting.
It's unfortunate you got COVID, but I would recommend a not smoking.
Yeah, so much better. Yeah.
What scared me is I had no idea that there was this big kidney issue. I was born with only one kidney, so finding out that there's such a big issue with kidney problems after COVID kind of shut me up a little bit. I can't lie.
Yeah. I mean, we've seen it's the ACE2 receptor is on most cells. What's also interesting about so there's receptor, and then there's the protease that's near the receptor that cleaves the SARS that cleaves the S protein in order for it to because it basically, think of it as like the spike protein on the surface of the virus is kind of like an uncut key, and so something in the body actually cuts the key perfectly, and that's called a protease. And in order, basically, if the room is the cell, the door is the receptor, and the virus, the spike protein, is basically the key. But it has to be cut by a protease, the key cutter, before it can enter, right? Yeah. And so there are people that have mutations in that protease that are not only resistant to coronaviruses, but they are also resistant to certain types of prostate cancer. And actually, 85% of people that get prostate cancer have a weird mutation in that gene. Right? Again, we will have to learn more about people that have mutations that make them resistant. Because if we, figure that out, we can design drugs around that. As well, bats will be a fantastic tool for us to understand. And we believe that bats carry all these viruses because they have to fly. And so they had to turn down their immune system, right? Because flight makes all kinds of free radicals, all kinds of damaging free radical molecules. And so if they were in a constant state of inflammation, they would get cancer and have all kinds of problems. So bats dialed down their immune system, allowing them to fly. But then it also has allowed them to carry all kinds of viruses. You can have a bat infected with, SARS-CoV-2, SARS-1, Nipah, flu. I mean, it's amazing the capability of these viruses in bats. But the bats don't have disease, or at least it doesn't look like they're very sick, because the inflammation actually and the inflammatic response is what causes the damage. Perfect example of this is in like polio. The immune system wipes out polio really quickly. But when polio hides out in the autonomic nervous system, it also wipes out those nerves. And so people are bound to like iron lungs and they're paralyzed, right? And so same thing happens in COVID, where the infection gets going, the immune system goes with a scorched earth type of thing with neutrophilic attack, and then you get all this buildup of fluid in the lower lung, and you basically drown in your own fluid. And so if we can learn from bats and dial down and learn how to modulate the immune system, we might be able to have all kinds of viruses and not even know it, or even be able to care, right? Yeah. Because they don't cause disease. And so I think host response and as well antivirals and of course vaccines, but we should be in the process of eradicating diseases, and it shouldn't be a debate on whether we keep these diseases or not. It should be, yes, we will give money to eradicate these diseases, period.
Definitely, man. Well, Richard,
say that again?
Richard, I want to thank you for coming on. That's been much appreciated, man.
Oh, it's very welcome. Anytime. I'd love to come back. But yeah, no, I'd love to come back when we have more cool data to tell you about, or those kind of things. It's been a pleasure meeting both of you guys, and I hope you guys feel better with your COVID. Maybe in the future there'll be a therapy that we'll be able to provide to people that will help people feel better, or even screen people that have had COVID-19 susceptibility. I think that's the other thing.
Excellent. And for people that are listening, what we'll try and do is, if you want to share the podcast, you have to tag in Joe Rogan to the podcast as well. That's the best way to go about that.
I also want to admit I'm gonna do a little bit of self-promoting as well. You can follow me at your neighborhood virologist on TikTok. And you're welcome to, we're going to try to make some videos on there for people to look at for COVID. And so I'll say it again. So it's at neighborhood virologist on TikTok, and you can follow me there. And of course, you can, we're welcome to have answers or questions for us